Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. My name is Aiman Syahmi and today we will present our embedded group project which is about automatic temperature control fan. Before I start with the introduction, I will introduce our team members which are Ahmad Zuarif Amnan bin Zuhairimi, who is the leader of this project and he's responsible for simulation and hardware setup. The second team member is Aiman Syahmi bin Amrin, which is me myself, and I am responsible for presentation slide. And last one is Aliatul Tahirah binti Aminuddin Aftori, and she's responsible for completing project report. An automatic fan is without a doubt an upgraded version of a fan that requires manual control of the speed. This eases the work of the user due to its advantage of saving more time by adjusting the speed of fan itself according to its current surrounding temperature. This makes ideal to apply this reliable device in houses and offices. Our automatic temperature control fan also has the capability to save energy since it does not consume a lot of electrical energy to function, hence saving electrical bill as well. I will leave it to Alitul Tahirah for the methodology.
Alright, my name is Ayla Tutanyura binti Amin Aftari. My name metric is 222060354. Now I will be present about the methodology. So in this methodology, we go through two things, which is the flowchart of our system and the code. So this is our flowchart. First, we start with select switch on. If no, the LCD will display fan off. If yes, the LCD will display speed of fan and temperature sensor. Next is the system will continue with the process in these three different conditions. So the first condition is if the temperature detect above the range 35 degree, the fan will speak to high. Second, if the temperature detect range of 13 to 35 degree, the fan will speed to medium. Third is if the temperature detect range 26 to 30 degree, the fan will speed to low. Other than that, if temperature range below the 36 degree, the fan will off. Last but not least, if we turn off the select switch, the whole system will be turned off automatically. So this is our flowchart system for automatic temperature control fan. So next is the coding. As you can see in this code, we include two library, which is liquid crystal I2C underscore hash for controlling a 16 times 2 character LCD and wire.hash for accuracy communication. Next is the variable. In this code, we connected LM35 temperature sensor to analog pin and the others to digital pins such as switch pin, input 1, input 2, and enable pin. Now we move on to the loop function. In this code, we're using MAP function, which will convert analog to digital, where from analog value LM35 temperature sensor, convert this to Celsius using a formula. After that, in this loop, we want to check if the switch is on, it will display the temperature on the LCD and adjust the fan speed based on temperature threshold. And if switch off, it will display default message on LCD and turn off the fan. Next is for the fan speed control. The fan speed is adjusted using PWM pulse width modulation. We are the analog right function to control the motor driver and enable pin. Different speed level are set based on the temperature threshold using conditional statement if else. Overall, this could create a simple temperature-based fan speed control system using an Arduino, an LM35 temperature sensor, an LCD, and a motor driver. So that's all from me.
Hey, hi, hello. My name is Ahmad Zorif Amnan bin Zuhairimi, number matrix of 222060351. And so I will be presenting about results and discussion right now. So this is the video. of hardware and simulation. So we'll see about the simulation first. So we will activate Arduino, and the LCD shows that. If we turn the switch on, okay, we'll change the LCD to the speed of the fan, the current speed of the fan, and the temperature, the surrounding temperature. So if we adjust the temperature sensor to around 28 Celsius, then the speed is low, and as you can see in the RPM, it's quite small, but it's around 3411 RPM. Yeah. And if we adjust the temperature sensor to around 31 Celsius, then okay, if we pause right there for a bit, the speed will be medium, the speed of the fan actually. Temperature shows 31 Celsius, and the RPM is around 6000 RPM. And now for the higher speed, we need to adjust the temperature sensor to a hot temperature. For this one, I set it to 38 Celsius. As we can see, the speed shows high, and it's around 9000 RPM for the motor. So it works, the simulation works. And if we switch the switch button again, it will show the brand name and also the current state of the fan, which is the fan is off. Alright, that's it for the simulation. Now we're going to move on with the hardware. So right here, I was in a room with an air conditioner, and I was under a fan, so it should be a very low temperature. I switch the switch on, and there we go. Yeah. So now we're moving on to medium speed. I put a box over there so that the fan won't vibrate that much, and it's easier to record, by the way. And now high temperature. As you can hear from the sound of the fan itself, yeah, the sound is quite actually quite loud. That's because of the RPM is very high. Okay, next slide. So I'll show about the results based on the table. If we transfer it to a graph, then it will show that the RPM of the fan increases linearly with the temperature. So here on the table, like just now, we recorded the RPM of the fan based on the simulation before this. So if it's 35 Celsius, then it's off, 0 RPM. If it's 38 Celsius, speed of fan is low, around 3114 RPM. 30 Celsius, speed of fan is medium, which is around 6227 RPM. And if it's 36 Celsius, then speed of fan is high, which is around 8383 RPM. Yeah. So about the discussion, we set the fan so that if the temperature range is 27 to 29 Celsius, then the fan speed is low. If it's 30 Celsius to 34 Celsius, then the speed is medium. And if the temperature is more than or equal to 35 Celsius, it will trigger high speed. And based on the results, that's how it is done. It works, both simulation and the hardware. And as I said before, the RPM of the fan versus the temperature. RPM of the fan increases linearly with temperature, somewhat linearly actually. It's not accurately linear, but it's somewhat linearly, increases linearly. So in the end, it works. Our project works, and this temperature, when it's detected by the temperature sensor, it will convert it to voltage, which will be detected by Arduino. That's why we use map function in the code. Okay, now for the conclusion, all three goals are achieved. The first one is that our team managed to design an automated fan which adjusts its speed based on temperature in Tinkercad. And secondly, in order to complete our design, we combine all our knowledge about this syllabus, which precisely is about motor, temperature sensor, I2C LCD, and motor driver. And finally, we also thoroughly analyze the performance of our automated fan system, which just now we made a table and a graph. Okay, so now it's about the recommendations. So the first recommendation is that replace the LM35, which is the temperature sensor, with a thermistor, which works by its resistance varies with temperature. It is much more accurate as well. This is because one of the flaws of the LM35 is that it is self-heating. So sometimes, for example, if it detects medium, let's say 35 Celsius, or maybe let's say 31 Celsius, 31 Celsius, and then suddenly it will fluctuate to 36 Celsius. It's because it's self-heating, because it receives input of temperature based on voltage. Yeah. And for the second recommendation is that we have to add an emergency push button to shut down the whole system, because actually our system does not have one. So just for safety reasons, we recommend doing this. And for the third recommendation is that actually another flaw is that the motor, when our system detects high temperature a very long period of time, for a long period of time, the motor will run at high speed for a very long period of time, which heats up the motor as well. So our recommendation is that we have to place another temperature sensor near the motor and turn the system off when high temperature is detected until DC motor has cooled down. Another recommendation for this flaw is that we add a liquid cooling system to the motor. Now there are actually two other recommendations, but that one will be explained further in the report. Alright, that's it from me. Thank you very much.
Commercial potential and cost of project management. This product is designed for indoor use in places like home, offices, and classroom. Given the weather in Malaysia, our company could make a lot of money by selling it. Our product is an alternative to air conditioner. It cools spaces automatically like an air conditioner, but doesn't release harmful chemicals into the air or use as much electricity. This saves users money on their electric bills. We've kept manufacturing costs low by using readily available materials. If we buy some components from other companies, we can save even more money. For example, a high quality motor driver costs at most 20 ringgit. We brainstorm and set the product commercial selling price to be only 150 ringgit. To make a huge sum of profit, we just need to sell the product for a bit more than it costs to make. That's all for our group project presentation.